Iteration. In presence of mixed acid, that is concentrate H2SO4 plus concentrate HNO3, it gives the nitrobenzene. That is approximate 50 degree centigrade temperature. See the next is how the nitro group is introduced to the benzene and how this electrophilic aromatic substitution takes place. That is generation of electrophile. H2SO4 is dissociated into H plus plus HSO4 negative. This H plus protonate the HNO2, HNO3 and gives the nitronium ion. This nitronium ion acts as electrophile. ये हमारा electrophile. Next it is attack of electrophile. Attack of electrophile is the RDS. It forms the sigma complex. Deprotonation. Which gives nitrobenzene as product. So you see the corresponding graph. Benzene, sigma complex, reaction coordinates, listen, now see the characteristics of the reaction. Actually there are two acids, one it is concentrate H2SO4, another is concentrate HNO3. Out of these two acids, one acid acts as acid, another acts as base. It gives the proton HNO3 accept the proton. This acts as base. So overall, electrophile nitronium it is generated. Nitronium ion attack करेगा. Nitronium ion itself it is as electrophile. Sigma complex, which is resonance stabilized. And finally, deprotonation gives the nitrobenzene. See the characteristics of reaction. First, attack of electrophile is the RDS. Attack of electrophile is the RDS. Second, out of these two acids, one act as acid, another act as base. And one more thing is, there is no kinetic isotopic effect is observed, means the rate of reaction with C6H6 and rate of reaction of C6D6, it is similar. Kinetic isotopic effect is not observed, that is, rate of nitration that is C6H6 is equal to C6D6 is equal to C6D6. Third point, out of two acids, this nothing, it is called as a mixed acid or nitrating mixture. Or mixed acid, it is also called a mixed acid. That is concentrate H2SO4 and HNO3. H2SO4 act as an acid and HNO3 act as base. HNO3 also is oxidizing agent, so oxidation also takes place with phenol. HNO3 is also oxidizing agent, which oxidize the phenol, into parabenzoquinone. Identify the product, identify the major product, identify the major product. प्रोडक्ट क्या होगा? that is major product. See the product. In case of first, it is orthopara directing, but ortho position it is sterically crowded. That is why product, major product it is para nitro, and also we obtain ortho. This is as a major. CS3 also orthopara directing. Ortho position it is sterically crowded. Para will be the major product. Here it is activating ring. This is deactivated ring with respect to para will be the major. Case of this it is deactivated ring. This is activated ring with respect to this para is the major. Here it is 1 alpha H, here it is 3 alpha H. So the hyperconjugation, its sigma complex it is more stable. Electrophile attack to that position which gives more stable sigma complex. So sigma complex, if it attack also to CS3, it has 3 alpha H which stabilizes the sigma complex. That is why major ortho to CS3. It gives meta as major product, but if it is phenol, then we also obtain the oxidizing product, means it gives the oxidizing product as major. It oxidizes and gives major product as parabenzoquinone. Plus citric acid as minor. This is as major. So suppose we want this, orthopara of this phenol, orthopara nitrophenol. If we want this as a major, interconvert. Phenol to orthonitrophenol or paranitrophenol. What to do? This is our target. If it is directly nitration, it is done. It gives the oxidizing product. This is oxidation product. This product, it is oxidation product. Electron releasing group favor the oxidation reaction. Rate of oxidation reaction is directly proportional to the ERG or releasing tendency of the group. Electron releasing tendency. Electron, that is note ERG, electron releasing group, or EDG, electron donating group, in favors the oxidation reaction. तो क्या करें? हम तो चाह रहे हैं कि ये ऑक्सीडेशन ना हो. OH, it is strongly activating group. Then what to do? In that case, मैं कुछ ऐसा करना होगा जिससे कि इसका ऑक्सीडेशन प्रोडक्ट ना आए और मोनोनाइट्रेशन ही हो. इसकी रिएक्टिविटी कम. जैसे OH ग्रुप को एस्टर में कन्वर्ट कर देते हैं. एस्टर में कन्वर्ट करते ही वो हो जाएगा मोटिलिटी एक्टिवेटिंग ग्रुप और फिर उसका ऑक्सीडेशन नहीं होगा. फिर नाइट्रेशन करके हाइड्रोलिसिस कर दें. मतलब दिस इज अवर टारगेट. ये हम चाहते हैं कि ये बने. तो कैसे इसे इंटर कन्वर्ट किया जाए? सी, अगर डायरेक्ट कर देंगे तो हमें इसका ऑक्सीडेशन प्रोडक्ट मिलेगा मेजर. तो डायरेक्ट नहीं बल्कि इनडायरेक्ट करते हैं. डायरेक्ट वी कन्वर्ट द फिनॉल इनटू पैरानाइट्रोफिनॉल एंड ऑर्थोनाइट्रोफिनॉल. सीधा सॉल्यूशन. First of all, acetylation is done with acid anhydride or acid chloride. COO, CH3, or the same reaction it is done with acid chloride. It attack. It pick up the electron. When it return CH3CO negative, it goes outside. या ये रिमूव हो जाएगा. क्या बनेगा? पहले एडिशन हुआ, फिर एलिमिनेशन हुआ, minus CH3 COO negative. Further, this CH3 COO negative, it extract the acidic H. Now nitration it is done. HNO3 plus H2SO4. It gives orthopara product. Because it is moderately activating group. Its lone pair, it is participating in resonance with a C double bond or benzene. So its reactivity is less, no oxidation takes place. इसका ऑक्सीडेशन नहीं होगा ये नाइट्रेशन करेगा ऑर्थो एंड पैरा पर, पैरा मेजर आ जाएगा। अब क्या करें, इसका अभी तो हमें प्रोडक्ट नहीं मिला, हम चाह रहे थे क्या, ऑर्थो नाइट्रोफिनॉल एंड पैरा नाइट्रोफिनॉल, इसका एसिडिक हाइड्रोलिसिस कर दें। इफ द एसिडिक हाइड्रोलिसिस ऑफ एस्टर इज डन, अगर हम एसिड इसका एस्टर का एसिडिक हाइड्रोलिसिस करें तो यहाँ क्या CH3COH एंड OH, क्या बनेगा, ये तो ये हाइड्रोलिसिस हो जाएगा, एस्टर का हाइड्रोलिसिस होकर क्या बनेगा, एक तो OH आ गया ग्रुप, OH पैरा नाइट्रोफिनॉल प्लस ऑर्थो नाइट्रोफिनॉल प्लस CH3COOH। Similarly, we want to interconvert aniline into ortho-para-nitroaniline. If direct it is done, then it gives meta product because NH2 group, it converts to NH3 plus. How to interconvert this? Aniline to interconvert aniline to para-nitroaniline and ortho-nitroaniline. Again, acetylation first. To direction it is done, it is converted into NH3 plus, which gives meta product. So indirect again. First acetylation. Acetylation is done either base or you can also use acid chloride. Same acetylation takes place here. क्या बनेगा, so it is NH2 NH positive NH positive, convert into secondary amide. Now further hydrolysis. Before hydrolysis we have to go for nitration, that is concentrate HNO3 and concentrate H2SO4. It gives ortho para product NHCOCS3 para nitro and ortho nitro product further hydrolysis, acidic hydrolysis HOH plus, it convert into the corresponding acid and NH2, acid and NH2. Minus so we have done it is indirect. Directly it is protonated. If direct reaction it is done, direct nitration if it is done, then it converts NH2 into NH3, which gives the meta product. So no direct interconversion. Again other nitrating agents. Other than concentrate HNO, first this is already we have done, that is concentrate H2SO4 plus concentrate HNO3, that electrophile it gives nitronium, you can also use HNO3, concentrate HNO3, it also gives the nitronium as electrophile. In this case, one of the molecule it gives proton, another HNO3 accepts the proton. So we see that how the nitronium it is formed. HNO3 dissociate into H++, NO3 negative. This H plus, it gives the product, it gives the proton means acid base reaction, it converts OH into OH2. Now this nitronium it acts as electrophile. Third, you can also use FNO2 plus DF3. It also gives the same nitronium. It absorbs the F, DF3. The nitronium is formed. Fourth, HClO4 plus HNO3. HClO4 gives the proton, it accepts, and it also gives the nitronium. NO2 positive as electrophile. Number 5, here it is HNOH2, one more it is HNO2 plus HNO3. It gives nitrosonium as electrophile, which oxidizes into nitronium. Which oxidizes into This is nitrosonium. Sixth, N2O5 on heating, it also gives the nitrogen. How it gives? It breaks down into NO2 positive and this act as electrophile. So these are the others nitrating agent. This nitrosonium, first it gives, suppose the reaction it is done with benzene. HNO2 plus HNO3, it forms the nitrosonium. So first we obtain nitrosobenzene. Further it oxidizes in presence of HNO3. That is oxidation. Oxidation takes place and it converted to nitrobenzene. Sulfonation. When benzene is treated with concentrated H2SO4, on heating it gives benzene sulfonic acid at approximate 80 degrees centigrade temperature. Here it is, we see the mechanism. Mechanism H2SO4 dissociate into H plus and HSO4. ये जो H plus है, ये दूसरे मॉलिक्यूल को क्या करेगा? प्रोटोनेट करेगा. और बनाएगा HOH प्लस H double bond O OH, which dissociate into H2O plus OOH. Again it gives SO3 plus H plus. This acts as electrophile. It can also be act as electrophile. ये भी electrophile की तरह act कर सकता है. SO3 भी electrophile की तरह act कर सकता है. SO3 because it is very fastly it converts into SO3. So this act as electrophile in maximum molecules. So we see that attack of electrophile. This electrophile it attack as electrophile dominantly. It gives sigma complex which extract the proton and convert into the benzene sulfonic acid. Characteristics of reaction. First thing important is kinetic isotopic effect is observed. Kinetic isotopic effect is observed in sulfonation. It's important property, that is rate of sulfonation is C6H6 is greater than C6D6 than C6T6. If D is taken in place of H, rate of reaction increases. That is, if we see the graph, again this is with C6D6, this is with C6H6, TS1, TS2. Reaction coordinates. So we can say removal of D positive is the RDS when C6D6 is used. Removal of D positive is the RDS when sulfonation of C6D6 is acid is done. Another important point is oleum is better sulfonating agent than concentrated H2SO4. Oleum, that is concentrate H2SO4 plus SO3 or H2S2O7 is better sulfonating agent, is better sulfonating agent than concentrate H2SO4. रीजन क्या होगा? ये जो H2SO4 है, कंसंट्रेट H2SO4, ये जैसे जैसे हमारा इलेक्ट्रोफाइल बनेगा ये डाइल्यूट हो जाएगा, बिकॉज वाटर मॉलिक्यूल इज एब्स्ट्रैक्ट व्हेन इलेक्ट्रोफाइल इज जनरेटेड. तो अगर कंसंट्रेट H2SO4 हम यूज कर रहे हैं, उसके मुकाबले H2SO4 plus SO3, that is oleum, is better because it again convert the water molecule into H2SO4. This oleum plus H2O, oleum plus H2O, that is H2S2O7. It gives 2 mole of H2SO4. It converts the water molecule into again H2SO4, so no dilution. So no dilution of sulfuric acid. डाइल्यूशन नहीं होगा उसका. अगर डाइल्यूशन हो गया तो हमारा इलेक्ट्रोफाइल नहीं बनेगा. नंबर 4, desulfonation easily takes place desulfonation easily takes place when benzene sulfonic acid is heated with H3O plus or HCl, and it is sulfonation and desulfonation, it is important property to protect the site. If it is H3O plus on heating or HCl approx 150 degree centigrade temperature, it gives benzene plus SO3. This is called desulfonation. Number 5. When sulfonation of phenolate is done, degree centigrade per at 25 degree centigrade, it gives major as ortho hydroxy benzene sulfonic acid. If it is approx 100 degree centigrade पर पैरा मेजर आएगा, because chelation it is break down at 100 degree centigrade temperature, so para will be the measure. This is the measure, and at low temperature this is the measure product. If we see this specific site of sulfonation, it is very important property. In this case, what happened exactly? If suppose we want to block any site, then we can go for sulfonation. First, another reaction, again we can remove this SO3H by desulfonation process. For example, suppose our target is to convert the phenol into orthochlorophenol. Then how to achieve this one? How to interconvert? कैसे इंटरकन्वर्ट करें इसे कि फिनॉल से हमें बनाना है ऑर्थोक्लोरोफिनॉल. पहले क्या करो, सीधा सॉल्यूशन. अगर हमें डायरेक्ट हेलोजिनेशन करा दिया तो क्या होगा, पैरा पर आ जाएगा Cl, मेजर प्रोडक्ट तो वही दे जाएगा. क्या करो, सबसे पहले सल्फोनेशन, पैरा पोजीशन को प्रोटेक्ट कर लिया, दैट इज कंसंट्रेट H2SO4 at 100 degree centigrade temperature. It gives. Now go for halogenation. AlCl3Cl2. It gives orthochloro. Now desulfonation takes place when it is heated with H3O plus, HOHH plus. Then desulfonation takes place. Prophenol. So this is useful to protect the site, protected site, or block the site by SO3H. Protected site, that is parasite, or blocked site. Halogenation. We obtain the halogenated product. See the mechanism. First, second, if it is bromobenzene, see the mechanism first. Generation of electrophile. This is called chloronium. Attack of electrophile. This is a RDS from the sigma complex. Deprotonation. क्या करेगा ये H प्लस को रिमूव करेगा, क्या बन जाएगा, इससे बनेगा क्लोरोबेंजीन. प्लस see the mechanism second. It is also similar, but complex. It acts as electrophile. In case of third, it gives I plus. If the halogenation it is done with phenol, it gives monochrome product, that is ortho and para product. Carbon disulfide is non-polar solvent and water it is as a polar protic solvent. See the mechanism how we obtain this one. Why it gives non-polar solvent gives only monochrome product, monohalogen product. On the other hand, it gives tribrome product. See the mechanism. It is non-polar solvent, so it is less reactive, but in water it dissociates into, that is suppose A, this is suppose B. Mechanism of B. In water, this phenol it dissociates into phenoxide ion and H plus. This is phenoxide. This phenoxide it is O negative is more reactive now, so it gives the product. 3 times ES takes place. It is very much nucleophilic. It attack from para further again at ortho, that is ES, again one more time it reacts with Br2, now take the proton, In water they dissociate into phenoxide, which is more reactive than phenol. That is why 3 position, all these ortho and para position, it is occupied by Br, and we obtain the tribrome product. This is as a tribrome product. On the other hand, this is non-polar solvent, so it is not reactive. That is why it gives monobrome product. Similarly, if the reaction it is done with aniline, either it is non-polar solvent or it is polar solvent. In that case, it gives tribrome product, Br2CS2, Br2HOH. Either it is polar or non-polar. It gives the tribromo product, that is in place of Br2. If it is Cl2, then also we obtain the tribrome chloro product. Here it is, if it is Cl2, ortho and para chloro. If it is Cl2 with HOH, then also trichloro product we obtain. Means phenol dissociate into phenoxide. Phenoxide O negative, it is more reactive than OH, but here it is NH2, it is more reactive than OH. So tribromo product is obtained. It is better electron releasing group, ERG, or electron donating group, plus M of NH2, it is greater than NH2. NH2 is greater than OH. So its nucleophilicity is more. That is why in polar or non-polar itself it gives tribromo product. Bromo decarboxylation. If COH group it is present with respect to OH at ortho or para, then Br2 in HOH, it gives tribromo product and decarboxylation also takes place. क्या होगा, यहाँ ट्राइब्रोम प्रोडक्ट होगा और ये CO2 की फॉर्म में निकल जाएगा. कैसे? See the mechanism. This phenol and COOH it dissociate into corresponding ion in water. क्या बना देंगे? ये बनाएगा O negative, COO negative. Now CO negative it is weakly activating group. It's plus I, it is strong plus I. It is also it is strong plus M plus I. Therefore its nucleophilicity is more. It is at para position, COOH. So it dissociates into corresponding ions. Next, bromination takes place. First bromination, Br2, EAR. Further again bromination. Again this side bromination takes place like previous mechanism. Now again bromination takes place at para position. Now there is no proton to release. In place of deprotonation, decarboxylation takes place. It is decarboxylation takes place. How it takes place? कैसे decarboxylation होगा? ये बनाया CO2, it is stable molecule. यहाँ से ये remove हुआ और decarboxylation हो जाएगा. Minus CO2. Removal of CO2 is known as decarboxylation. क्या बना? Tribromo product. ऑर्थो पैरा पोजीशन पर क्या आ गया? Br. Yes or no? O negative. Finally take the proton and gives the tribromo product. The same reaction it is done with if it is at ortho position, that is bromo decarboxylation takes place if it is at ortho and para. If it is at meta, because it gives after removal of this, it converts into aromatic. So there is no decarboxylation at meta position. Here it is. If it is at ortho position, then also decarboxylation takes place. COOH. The mechanism will be same. Means it remove from ortho and para. Br2HOH. Br2 HOH. It gives tribromo product. It is removed from ortho and para. Also similar, bromo desulfonation. It also same mechanism. Here it is remove SO3, bromo desulfonation. At ortho and para position, the same mechanism, desulfonation also takes place.